Zoom. Okay. I assume you can see my screen. Otherwise, please shout out because I don't really know whether it was really shared properly, but I see the screen was shared. Okay. So this is the second group meeting for the ACSL contest. Just in case you are not really pay attention to the first meeting, I just give a brief description about what's the ACSL, American Computer Science League, American Computer Science League. Yeah, it's really a contest for the team to compete to each other, but each individual will have its own tracking record. So it's really very fun, and most of you, if not all of you, may already take the first contest. So you got the feeling. You need to register high rank account, and then you have to take the test from the website. I think you already got through the first contest, so I hope you get more familiar with the whole process. For each season, we have 4 contests. So besides the first one, we have another 3 ongoing. And of course, I introduced our group, our club a little bit, Youth Coding and Innovation Club. Most of your parents already know us, so you can use the YCIC. If you have interesting, you can go to check our website. Let me see, where's the website? I forgot. Okay, it's ycic.club. So yeah, if you go to here, you can see ycic.club. Okay, so that's our website. Yeah, something like this. Yeah, you can tell it. So that's really list a lot of contests, and we have project, we have news, something looks cool. So you can check it out if you have interesting. And for the schedule, the first contest already done. So you do not have to worry about this one. And we are preparing for the second contest. It's really, for our club, I don't really talk about the deadline. The deadline is slightly after March 2nd, but our deadline is between February 25th to March 2nd. It will depend on how we are ready for that. I don't really try to rush, but on the other hand, we cannot really wait until last minute, because especially for the junior division, you have a 72 hours coding period. You do not start on time, you will get out of the window. So that's not really something you want to see. Of course, the third one is April, and the fourth one is May. Okay, so very, very important. We share the previous year's contest material on the Google Classroom, but you do not really want to share this to your friend, because that's really not our policy. It's a policy from ACSL, so we cannot leak their material. So that's all copyright. So we cannot do that. So that's very, very important. Just make sure you use this for the practice purpose only, but you do not really use this to, of course, you can probably discuss with your friend for one question, but you do not really share this whole material with your friend. So that's, I can tell you that's illegal. So that's why. Okay. So we post the classwork over here, and all of this classwork are the real contest question from previous year's contest. Okay, let's start our topic number 1. This is the only topic for elementary division, and this is the first topic for junior division. So in case you have any question about that, you can shout out. Let me see if I can put the chat box out, but anyway. Okay, yeah, I put the chat box over here so I can see it. Okay, and the first topic is about the fix, not say fix, it's a prefix, infix, and postfix. We will talk about what's a prefix, what's an infix, what's a postfix, and how to convert to the prefix, how to convert into the infix, and how to convert into the postfix. Most of you, I hope, already goes through the document or the YouTube video I post over here. It's very, very important you spend some time to study this topic. Just like what I told you guys at the first meeting. We are not here to teach you us, of course, for different reasons, because we are really volunteer-based, so we do not want to give you extra burden and to both your parents and you. But on the other hand, we trust you can do your own homework. That's why we try very hard to make sure you can really follow up and understand this topic. Okay, so let's say the very first one is called the prefix notation. If we try to say A plus B, we could say add A, B. So that's really, as a natural language, you can convert into the prefix notation like this. So that's plus AB. So the A and B both are called operand. So you can see this word called the, okay. So this is A and B, it's called operand. And the plus means operator. So that's really say, what's the action you want to take? And these two you can consider as two different numbers, right? So think that's simple, like 5 plus 4. You can say add 5, 4. And here it's plus 5, 4. Okay, of course, we use AB to represent any number. Same thing is multiply. You have multiply AB, you can say A multiply B, and then you can convert as multiply AB. Then you can write as the prefix. So multiply, the operator is the first one, and then two different number we call operand. So this is called the prefix notation. I just give you some very short and easy to understand description, so you do not really get confused. But we will have some of this demo. I will show you how it works. And now we move to the infix. The infix is really more like the natural language. Say, okay, instead of add AB, we can say A add B. So this is plus, right? So say A plus B. That's very natural, very easy to understand. So do the multiply, say A multiply B. So you can write the operator in between of two operands. So this is called the infix notation. So do the postfix notation. If you already understand what's a prefix notation, you can see the operator is before any number or the operand. And the infix is really in between, right? Now it's very easy to understand what's called postfix. The postfix is nothing really strange if you understand the first two. So that means if you want to add A and B, you can say AB add, right? That's the same thing. So you say AB add. Instead of try to make the calculation from the first one first, you can say, okay, you have the first number, and then you have operand, and then you have second number. For the multiply, it's the same thing. So you say AB multiply. So that's called the postfix. Okay. So I hope this is simple enough for you to understand. Of course, we will give you more explanation and go through some of this small exercise. So for each one of this notation, we want to remember a couple of keywords. That's very, very important, especially when you get confused. You do not really want to fall in the trap, say, oh, I remember something, but some other part of the notation I forgot. So I want you to remember that clearly you without doubt about the concept. So for infix notation, it's really the only one which can use the parentheses. So if you use parentheses, really they give you the highest priority. Let's try to break down, say, okay, now you have this. So how to evaluate this? So you have the evaluation really based on what we call the order of sequence. So the order of sequence is really defined which one will be calculated first. So the order of sequence here we will have the order from left to right. So that means this 2 is the first because that's far left, right? And then you have plus, and then you have 3. But do we calculate 2 plus 3 here? Yeah, you can. Actually, you can without any parentheses. But in general, we do not really fall in that category. It's because yeah, actually the exponent is higher than the parentheses. So yeah, that's a very good question. Yes. So in general, if you have parentheses, you have to use parentheses first. So that means if you want to convert this, say, okay, if you want to calculate 2 plus 3 first, you want to use parentheses. Then you have to multiply 5. So that means 2 plus 3, you have 5. 5 times 5, 25. Without that, what's the calculation? It's really like this. You will calculate the multiply and division first, then the addition and subtraction. So that means 3 times 5 will be 17. I'm sorry, 3 times 5 will be 15. That will be first. And then plus 2 will be 17. Okay, so that's how naturally it works. So without the parentheses, you are really able to make the decision. So you know the parentheses is always first. So if you have parentheses, you have this first. And another question is just like what we ask from Kevin, say, exponents, what's the order? It's really even higher than the parentheses. That's what I remember. I will double check that if I'm not wrong. Okay, so you have that first, and then you can use the multiply and division the second, and addition and subtraction is the lowest order. So basically, if you write something like this, the result will like this, not really like this, unless you want to use the parentheses to enforce the 2 plus 3 first. Oh, I'm sorry. I think the order of the sequence, or order of infix with yeah, I have to double check that. So I do not want to give you the wrong direction. I think the parenthesis is always first. Yeah, this one, yeah, I think this one is the second. Yeah. Right. Okay. So I just highlighted so you do not really get lost. Okay. So this is really about the infix notation. And then we talk a little bit about the prefix notation. The prefix notation, when you see it was write something like this, you can see the underline this line over here, right? So what that really means is that they really calculate the 3 times 5 first here. So that get 15. And then the 15 will plus 2 will be 17. But if you write something like this, you will get totally different result. This result will looks like 2 plus 3 will be calculated first. So you got 5. And then 5 times 5, that's the times, you get 25. So what's that prefix notation really mean here is that you do not use the parentheses, but you will find the operator before the calculate. So you will find the multiply or plus before you make the calculation. The calculation sequence is from the right to left. So you do not really get confused. It's that, okay, you get something from here first, that's not prefix. Prefix, you will calculate from the right to left. So from the right side, you have 5 and you have 3, and then you have the operator. So now you say, oh, 3 and 5 is number, and then operator is multiply. Then you got the multiply 3 and 5. That's why you get 15. And then you move on, say, okay, you have 15 and you have 2. Then you find another operator. So you have the plus. That's where you get 17. Of course, you will have to use the far right operator first. So that means if you have this, right? So you have 3 number. What that really means is that you are really trying to find where is the first operator. So you check, oh, I have 2 operators here, but the first operator is really on the right side. So that's plus. Because one operator only apply for 2 operand. So that means you only apply for 2 number, right? So you have 2 and 3, that's plus. So 2 plus 3 is 5. Then you move on to try to use another operator. So that's 5 times 5 becomes 25. So you only need to remember is that for prefix, you try to scan from the right to left, not from the left to right. And then you always try to apply the first far right operator first. So that means you scan from the 5, 3 to 2, but now you have C1 operator. Then this operator will be applied. So you do not skip, say, okay, I just skip over to the multiply. No, that's not how the prefix will work. So that's really something very basic concept about the prefix. Okay, so now we move on to the postfix. I'm sorry, I skipped that. The postfix, if you see the example here, you have 2, 3, 5 multiply and plus. So how we make the calculation here is that you have 3 and 5, you will have the multiply. So now you get 15, right? And then you have 15 and 2, you have plus. So you plus this to become 17. So you can see they are really the same result. But I will explain to you why they are right in the prefix and postfix notation. Either way, they can get the same result. Okay, and now you can see this one. You have 2, 3 plus. 2, 3 plus will be calculated first, you get 5. And then you 5 and 5 have a multiply, then you get 25. Okay, all of this example is really simple, but I want to give you the foundation of the concept. So for postfix notation, you also do not use a parenthesis. Do not really need to use that. And you will find the operator before calculation. So do the prefix, right? Why you need that is because any number here, you do not really know what we're going on, but until you see the first operator. But very important is the postfix, you will scan from the left side first. So that means you scan from the 2 first, scan from the 2 first. And then when you see the first operator, you will start to make the calculation. So that means the far left operator will be the first one to be calculated. That's why when you scan this number, 2, 3, 5, you never see the operator until you see the multiply. So the first multiply will be applied to this 2 numbers, 3 and 5. So they are 3 times 5 becomes 15. So to here, you already have 2 numbers, but then you have 1 operator here. So that's why you will have the 2 plus 3, because you already have 1 operator. So you will apply that, you get 5. Now you continue scanning 5, 5 multiply. So that's 5, 5 multiply times So you get 5 times 5. So that's 25. So to here. Okay, so you do not have to remember everything. You just need to remember what I highlight here. From left to right, and the left operator or the first operator, when you see, you just make the calculation. So that's the post notation. And for the prefix notation, it's scanning from the right to left. So that's reversed, right? It's not very natural because all what we learned, it's try to make the calculation from the left to right. But don't worry, when you go to deal with the prefix notation, you always remember, okay, I will scan from the right to left. And when I see the first, of course, that's far right operator, I will start make the calculation. And remember, the calculation only apply to 2 number. So that's why even you all have 5, it's a first number, but it don't really apply here because the plus only deal with 2 number and it's a closed to number. So that's why you have the 2 plus 3. Okay, so that's very high level description, and I hope you get the idea. I think the infix notation is the easiest one and easy to understand because you only need to remember is you have the left to right, and then you have the parentheses, you have the exponents, and then you have the multiply, division, and the lowest order is addition and subtraction. I don't know why it's subtraction. Okay, sorry, I got it. Okay, so that's very easy, and I hope you can understand that. So now let's do some quick exercise. And I know I use the same example from the ACSL because I found this one is complex enough, but on the other hand, it's not over complex. So they give you the chance to really explore almost all of this concept. So here, very, very important, when you see something right like this is really how you learn from the math class, right? But just remember, I have a quick question first. So if for most time we use the infix, why we still need the prefix? Or say, why we still like to learn the prefix and postfix? So say, what is the purpose for prefix and postfix? Anybody thinking about this question? So why we still need this? Sometimes computer use prefix and postfix. That's a good good answer, but not really just because they use. So why we use the prefix and postfix? So why we cannot say the is infix sufficient for most of the case? Okay, prefix are easy to program in computer. That's a good answer. Jason Lu, you have a good answer. So you probably can give me a little bit more details about why the program is easier to deal with the prefix and postfix. If you can think about that, that's okay. If you cannot, I give you some hint. So if you compare the infix and prefix and postfix, what's the really difference between them? Do you pay attention to that? So if we are talking about infix, prefix, and postfix, do you see what's really the difference? What the infix hide or use, but the prefix and postfix, they never touch or they never care. Parentheses, that's a great answer. Sophia, you got it. Okay, great. Jeffrey, you also got the right answer. So let's think a little bit harder. Say, why the parentheses is so important for computer program, or say for computer to really say more efficient. I can give you the hint. It's a priority system. That's partially right, but we have some other thing. Other part of the characteristic of the computer programming is more important. It's because anytime you have use more operator, because parentheses, of course, is operator, right? So that's really like the constraint. you are group something, you are really use more memory. That's very important because for computer, you know, two most important resource. One is the CPU power, another one is the memory, right? So if you use parentheses, definitely you use more memory. Okay, that's a very good interactive. So I got a lot of answer from yours. That's great answer. I really love your guys to be more interactive here. Okay, really cool. Okay, so now let's move on to this exercise. I emphasize the parentheses. That's why the parentheses is really very important, especially when you try to convert between this. So I show you why they are really important. Let me see if I have a whiteboard. Okay. Okay, I have a whiteboard here. I make this slightly smaller. Okay, so you can see both, right? That's great. So now you can see in math class, you can just use the up arrow. Yeah, up arrow is good enough. I don't think you can really use something like this. They are print like this. I copy paste. They do looks like this, but you do not really have that in the keyboard. Yeah, I realize that that's impossible. So you just use the up arrow. That's perfect fine. So don't worry about that part. So when you see this, right, as a math formula, right? The first part is that you try to convert into this. Okay, don't get confused when you see they even have the parentheses after everything was settled down. It's because we want to use the parentheses as the priority system. So just like what you say, you want to group them together, right? So that's why you say, okay, now you already have parentheses here, so you keep this. So this one, it's really nothing but this part. Okay, and inside you have a times b, so you have a times b, but give them the parentheses. Don't worry about that. You will see how we use that. And then you see the c divided by d, so you have the c divided by d. You also have the parentheses. Pay attention to this one and this one. It's really this one, so don't get confused. But you have this power by, of course, you can use the up arrow. Don't worry about that. That's perfect fine. So this is really exponential here. So you have the e powered by e. Okay, so don't forget about the last parenthesis, get out. You can write that on the paper, so it's much easier for you to understand. Then when we try to convert this infix into the prefix, what you really need to do is that you get rid of all of this operator, include the assignment or say equal. So you do not keep any of this. You do not use the parentheses. You do not use the multiply, divide by, or the power by, power by. Okay, sorry. So you have only the number. So you have the x, a, b, c, d, e. Now you try to remember what's the difference between the infix and prefix. The prefix, it's really try to make sure every time you have the operator in front of the whatever you want to calculate, right? So now you will see what's the first you want to calculate in the infix. The first one is a times b. So you have the ab, you plus the, you put the times, the multiply right before the ab. And then you say, okay, you have the a times b, then you have the c divided by d. So you have found the cd, you put the divide by here. So you have the cd, before cd you have divide by. Now, what's the next step for the infix to calculate? It's the minus, right? So this a times b minus c divided by d. So you have the minus before, if you think about this is the whole group, right? I'm sorry, this is the whole group. So you put the minus before this whole group. And then you have the e, because you already have the E here, but this is powered by. So this powered by will be before this minus. That's how to include the E into this whole. I'm sorry, I include one more. So you just, yeah, you got my idea. It's from this parenthesis all the way to this parenthesis, not the far left one. Okay. So now you got almost everything. Then the last one is the X. It's very interesting. They use the equal to or the assignment in the question here. So you have to practice a little bit with this. In general, I don't really think they have a lot of place use equal to or assignment, but for the ACSL, since they already use this, so that's why when we practice, we still practice like this. So you have everything like this. So the last one, this is really applied between this group and this group. I'm sorry, you just forget about me. The last one, don't recalculate here. Okay, that's why you have the equal to in front of X. Okay, so you got all of this idea. You just make the calculation just like the infix. Every time you calculate one, you just put the operator in front of the what's the number you are calculate. So you have A plus, A times B, you have the times here. You have the C divided by D, so you have the divide by in front of here. And then you have this group and this group are really minus. So you put the minus in front of these two groups. Yes, you're right. And then you have the power by E. So then you have the power by E here. And the E is really after this group. And then the last one is between the X and this whole group. That's why the X is here, but the assignment or equal to is put in front of that. Okay, so that's, hopefully you can understand that. That's simple enough. Now we use the same method, but this time we are really converted into a postfix. So in the postfix, you are really think reversely. Instead of put the operator in front of the number, you put that after the number. So it's not really that much difference if you think about that. The same thing is that you have the A multiply B, so you have the multiply is after AB. You have the C divided by D, so you have the divide by after the CD. And then the next one is this group and this group, they have the minus. So you have the minus right after this whole group, right? So that's minus. And then you have the E here. So the E here, it's really the whole group powered by E. So you have the E and then you powered by, of course, again, you can use the up arrow. So because from our keyboard, we cannot really find this one. So don't worry about that. And the last one is that this whole group and this X, they have the equals. So you have equals put on the last place. So that's a postfix. So it's really not that hard to understand, but I found the parentheses, it's really super useful and it's very helpful. So that makes you much easier to trace. I strongly suggest you to follow this when you practice. I found this is much easier to follow and not really make much of this mistake. Okay, we can do a little bit more of this exercise, but I'm not quite sure whether we have enough time. Let's try to quickly go through this one. I will ask Vian to demonstrate the last two. Okay, so this one is from the infix to postfix, and same thing is here. You have the 3 times 4 and A divided by 2, and then you can see the a little bit tricky is 7 minus 5 first. Okay, so you are really, oh, I'm sorry, I think I just got this first. Okay, so we are convert by side first. So this is the first step, right? So you got this is infix. And then from this infix, you will try to use each one of this group to move this operator in front. So you find the far right operator is the power by. So you move this to the first place. And then you find the next one is from here. So you have the minus. Okay, but don't get me wrong. This minus only apply to 7 and 5. That's why they are not really move the minus over here. Instead, they only move right before the 7 and 5. The whole reason why the power by moved to the first place is because they are applied to these two different group. So you are really not really moved to anywhere in between. Instead, you move all the way to the very first place. But this one minus, it's only applied between 7 and 5. That's why you have the minus here. And then you can move forward and you see the plus is between these two different groups, right? So the parentheses already applied here. So you have the plus move ahead here. Then you have the times, okay, times between 3 and 5. Of course, you have the 8 and 2. Oh, I'm sorry, I skipped this part, but in general, you are really scanned from the right to left for, I think this, I'm sorry, I think this is the prefix. It's not postfix. This is something, okay. So that's how you get this one. Okay, and now I will like to ask Yuan to share his screen and demonstrate this to exercise. Okay, I will stop sharing and then I ask you.
All right, let's see. Let me share my screen. All right, so hopefully you can see my screen.
Yes.
And this is going to be prefix to infix here. So we start off with this first statement right here. And this is clearly an infix because we have the operator here first. So to convert it, we're going to have to start establishing what matches with what. So the first operator, we have the exponent operator, that's the arrow. And then the exponent obviously needs two numbers, so we have to establish what numbers first. So next let's use this with black, that's the first level. And then the second level is going to be the plus. The third level is going to be the times. And the third level has the 3 and 4, so that's the third level. So we've reached the end now since there's no more to see. So times 3, 4, and then we have another level, which is the second one. So slash and the 8, 2. That means since we've read these, we now know that the plus will do something on these two. So then we can start grouping them like that. And then now we know the first operator of the exponent operation. So it's like this. And then secondly, we see the minus operator, and we see the 2 it does it on. So then we know that like this. So then once this is done, we can sort of establish, right, we're kind of trying to convert to infix here. So we can sort of write it out now. So if we have, so that means there's going to be something like this, and something up here. And then inside here, we have a plus symbol with the times 3, 4, and the divided by 8, 2. So that means that we have something plus something. And the first one is going to be 3 times 4. The second one right here is going to be 8 divided by 2. So like that. 8 divided by 2. And then finally, we have filled out that part. We have the final 7 minus 5 here, so we can fill that out in the exponent. So then there we go, we've converted the prefix to infix. And the second one that we wanted to take a look at was the postfix to infix. So the way this works, we have it at the end now. So postfix, we're going to have to look backwards. So we look backwards, we see this. That means we're going to have to establish the two operators. That means one of them is going to be this minus 7, 5 here. So that's one of them. And the second one is going to be the plus. And then the third one, then inside the plus, we need two numbers at the end. So we have the 8 divided by 2 and the 3 times 4. So that means these are what the plus does. I labeled this wrong. So we have the slash and the times, and then the plus does things on these two groups. And finally, this whole entire thing gets done by the exponent symbol. So you can start writing this out now. So we see the exponent symbol. That means we're going to have something times something. And we see the 7 minus 5. That means it's going to go first. 7 minus 5. And then the second is going to be this. And so we're going to have a plus in the middle. And then we're going to see the 8 divided by 2. So that's going to be here. Then we're going to see the 3 times 4. That's going to be here. And that's really how we convert from postfix to infix.
That's great. Yeah, thank you. Yeah, and let me continue to share my screen. Yeah, so far we are really learning everything about the prefix, postfix, and infix. So that's really covers the first topic for the junior division. And for elementary division, that's the only topic you will deal with the context number 2. So yeah, if you belongs to the elementary division, you are free to drop off, because the rest of the session we will talk about the second topic and third topic. So that's only for the junior division. Yeah, thank you. I wish you have a good night. And then we continue for the context number 2 and topic also number 2. We are talking about the bit string flexion. This name is a little bit weird, but I will let you know why we call that, because it's really a general term to denoting the operation that can be done for the bit stream or binary stream. If you have ever dealt with the bit stream or binary stream, you probably will pay attention to that. It's really nothing besides 1 or 0. So that's what we call the binary string, right? So, but it has much more useful purpose other than that. So we are really divide that into 3 different small categories. One is called the bitwise operator. The second one is called shift, and the third one is called the circulate. So let's go through it one by one. I make it bigger so you can see it clearly. Okay, the first category is called the bitwise operation. We are really have to remember these 4 different operations. One is called not. So you can use this or this. I don't really think you can really type in from the keyboard like this. So you probably use this. Okay, or use and. The and, not, or, it's relatively simple and easy to understand. Unfortunately, this one, I don't really know how we can type in the keyboard, but you can write something like the XO. So that's perfect fine. So the not, it's really easy to understand. That means it's a reverse type. So it's a negation of each bit. For example, you have this is a binary string, and say you have a not this. So that means each 1 bit of this binary string will be reversed. Reverse means 1 becomes 0, 0 becomes 1, right? So that's very easy. So you get 1 becomes 0 and 0 becomes 1. So that's each number is flipped. So you can think about like they are flipped back. So that's not. So that's very easy to understand. Not is a very simple one. And then you have the and. And it's really some sort of logic. So that means you have 2 values. only if both values are 1, you get 1. You probably get confused a little bit if you never deal with the binary, but if you deal with binary before, you probably will not feel that much confused. So I will give you some quick example here. So don't really worry too much about if you cannot understand. Okay, so let's move to here. We put the text, the first one. I'm sorry. I don't know why I cannot move it, but anyway. So the first number is 1011011. Okay, so this is the first number. And then we have the second number. I hope this is good enough. Second number is 011001. Okay, let's move this a little bit. Okay. I missed one number. 1011011. Okay. 011001. Okay. So I think this is not a very good example. Let me try to explain to you a little bit late. We go through this first because this is first time I use a mirror, so I don't really very good on how to use this board yet. Okay, so basically you get the basic idea is that you must have two values, both are 1, then logically that becomes 1. If one of the value is 0, the end means you will get 0. Okay, so it's really the bit string and you will have the calculate between 2 bits. And the OR is really on the reverse side. So the OR of 2 value is 1 if one or both are 1. So that means for OR to become 1, you only need 1 bit to be 1. So for example, 1 or 0, they will become 1. But if 1 or and 0, that will become 0. So you just think about the AND, it's really require both to be 1, but or you only require 1 value, it's 1. So that's really the big difference between them. So that's why we call the logic OR and logic AND. And then XOR, it's really something called the you can call it XOR, XOR, or XOR. That means you will have 2 values are different, they will become 1. If they are the same, they will become 0. That's really logically very easy to get confused. But you just try to remember that is that the XOR means they try to see whether they are different. If you think from this angle, that's really easy to understand. For example, oh, the XOR for twins. So that means they are both are 1, then you know they are, if both are 1, so you know they are different. But if the both are the same, so for example, that's 0. So you try to say if they are different, oh, the twins is not different, so they are 0. But if you have 2 brothers, they are 2 years apart, so they are different. So you say, oh, they are different, of course. Are they different? They are different, so that's 1. If you have the twin brother, oh, they are the same. Oh, they are not different, so that's why they are 0. Think something like this. I know this part of the logic is a little bit easy to get confused, so that's why you probably need to pay more attention to the XOR, and I will think the NOT and OR is relatively straightforward. Okay, and for the bitwise operation, that really means to deal with each bit, you try to use the XOR and X and OR and XOR. I forgot to put the NOT here, but the NOT is also here. Okay. So we put that into one of this table for you to easy to understand and easy to remember. So if the operand are not the same length, so that's very important. The short one is paired. with 0 on the left as lead. So that's why when you see two numbers here, right? So you try to make the calculation between these two numbers. You see the first number have 1, 2, 3, 4, 5, 6, 7. They have 7 numbers. So they have the length is 7, but this one, the second one is 6. So how can we make the calculation between this? We are not calculate between 1, 0, or 0, 1, 1, 1 here. Instead, we have to really make sure we prepend one more 0 here. So make this are the same length. That's very, very important first step. So prepend or pad a 0 at the left side, make them to be the same length. That's very important. Okay. And then you can make the calculation. And the calculation by itself, it's not really super challenge. But again, the XOR is a little bit hard to understand, especially before you practice. Okay, so let's say you have X and Y, both are 0. What's not X means? Not X means not 0. So that's become 1, right? And what's X and Y means? So that's X is 0, Y is 0. X and Y, oh, both are 0, and you are also 0. Oh, X or Y. So X is 0 or Y is 0, or both are 0, so it's 0. And X or Y. So that means is X and Y are different? No, they are the same. So they are not different. So you say it's 0. So that 0 means false. 1 means true, right? Are they different? No, X is 0, Y is 0. So they are not different. So it's false, that's 0. I know it's a little bit hard to understand, but try to think like this. Are they different? Okay, so if the next one is X is 0, Y is 1, and then not X is still 1 because 0 flip over, become 1. And X and Y, if you remember, what's the AND? AND means as long as you have 1, 0, you become 0. So now you have X is 0, so you are 0. But what's the OR? OR means as long as you have 1 is true, so 1 is 1, you becomes 1. So X or Y becomes 1. So OR means you only need one number is 1. You are already 1. AND means you only need 1, 0, you become 0. Okay. So and you always remember that they give the high priority to 0. So 0 first, you see any 0, 0 is here. And all give the high priority to 1. As long as you see 1, you becomes 1. But XOR is different. XOR means, are they different? Is X and Y different? Yes, here X is 0, Y is 1. So they are different. 1 here means true. So X and Y are different. Is that true? Yes, it is true. This 1 is here. So to here, you have 1, so not 1 becomes 0. And X and Y, you have the high priority to 0. You have 1, 0. Okay, it becomes 0. X or Y, you have high priority to 1. Okay, so you have 1 here, so it becomes 1. And then is X and Y are different? Yes, they are different. 1 and 0 are different. So they are different means they are true. True is 1 here. Okay, so that's very important. And then the last example is 1 and 1. Now you have not X, so not 1 becomes 0. And X and Y, you have any 0 here? No, you don't have any 0 here. So your only chance is you have 1, right? So X and Y are both 1, so you become 1. And X or Y means you look for the 1, and then you only find 1. Okay, so that's only 1. So you have 1. X or Y, so that means is X and Y are different? No, they are not different. So that means false. False is 0 here. So I hope you can practice a little bit. So don't get confused if you are, especially for this one. Okay. So now we'll talk about the what we call shift. The shift is really a logic operator. So we have the left shift and the right shift. We use the word river here. It's not really totally clear why we can use this, but doesn't really matter. You just need to remember that the very first one is that either to the left or to the right. So you will have shift out will get lost. So left shift means you shift to the left side. Right shift, it means you shift to the right side. But very important for this, if you get out of the whole length, you are really get lost. So you don't really keep it. So 0 or shift in at the other end. So that means if you are really shift, but you don't have that number, the 0 will shift on the other end. So let's say left shift 1. So that means you are really want to go to the left direction. Okay, so I delete this. Okay, try to use this number. 1, 1. Okay, so when we deal with this, we want to left shift 1. What we are really trying to do is that, so now we want to shift to this direction, to the left direction. And we only want to shift 1 bit. That 1 bit will get lost. So we will say, I put here, I'm sorry. So you will remove this 1. That's 1 bit. Then the rest of that 0, 0, 1, 1 will be kept here. But we want to keep the same length. At the end, you are pending 1, 0 here. You don't really say, okay, I move this 1, go to here. No, that's not. The shift operator, it really means you shift that out of the queue. You will get lost of this. So this 1 will be removed. So don't get confused. So let's do it one more time. So say left shift 1 means you shift to the left direction and only shift 1 bit. So this 1 bit will be removed. This 1 will be removed. And then, oh, I'm sorry, just write over here. You get 0, 0, 1, 1. It's what will be left. But you want to keep the same length. You pend 1, 0 in the end. So now let's try to exercise a little bit. So how about the left shift 2? What that will be? If we want to say we want to left shift 2, the same number here. Okay, that's great. Yes. So left shift 2 means you shift the first 2 bits to the left direction. So that means 1, 0 will be removed. You only have 0, 1, 1 left over. And you still want to keep the same length. So you have to prepend, or you have to pad 2, 0 here. So that's good answer, Jason. Okay. Now we exercise a little bit on the right shift. So it's pretty much the same concept, right? And we are really not have anything much different. Instead, to go to the left direction, we go to right direction. So let's exercise with this one. Okay, so I remove this. And I want to right shift 2 of this number, what this number will looks like. Don't count on this, count on this number. Okay, try to think about that. The right shift 2, 1, 0, 0, 1, 1. Okay, so what's the answer for this? So you will shift to the right direction. Good. Okay, so you are really trying to do is that you want to move to the right direction and remove the first 2 number, right? So what you left over is 1, 0, 0, because this first 2 number was left. was removed, but you still have to make sure you have the same length. So you will prepend 1, 0, 2, 0. So there becomes the same length 5. That's good answer, great answer. Okay. So now let's talk a little bit about the secret. Secret is really very, very similar to the shift. Besides one huge difference is that no digits will be deleted. So that means instead of remove this number, you are really circulate this number back on the end or on the head of the bit string. So let's give a little bit of exercise. Okay, so I just remove this one. Okay, so for the R secret 3, that means you are really go to the, I remove this number so you don't get confused. You are really move to the right direction and you operate 3-bit. So that means the 111 will be not removed, it will be recycled. Okay, let me try to do this, not 111, 101. Okay, so anybody can give me the answer of this? Right circle 3 10101. Yeah, I'll give you a couple of seconds. Okay, great. So let's see how we'll really deal with that. Is that we'll really move each one of the bit, but we are not really remove this. Instead, we are really move that on the back side. Oh, here it's really moved to the head because we are go to right circle, right? So that means we are really moved to 1 0 0 1 0 1. Sorry, 1 0 1 0. So that's really we moved this one, but this one will be add back to here. So that's 1. I'm sorry. This should be moved a little bit. Okay, yeah, they are not really perfectly aligned. So I hope you don't really get confused. Okay. Okay, so now you got the first one, and then for the next one is that you will move the 0, right? So the 0 will be removed from here and moved to the back side. And then the next one will be moved the 1. So the 1 will be removed from here instead add to the head over here. Okay, so that's very interesting and very easy to remember. So you probably don't really get confused by between the shift and secret. So that's very important. Secret never lost any of this bit, and shift will lost it, but they will use the 0 to add as extra. So that's something kind of important to remember. So we have the order of the precedent, and the order of precedent from the highest to the lowest is not, shift and secret, and XOR, and finally is OR. So on the other hand is that you are always have the rarely operator performed on a single operator first. So you can remember this, or you can practice and try to get used to it. That. Yeah, there are some of this simple example here, but I don't really think you will have the big problem about that if you understand what's a shift and what's a secret. It's not really that hard to understand, but you probably need to practice a little bit. We have the practice for this whole week, and I see a couple of students already send back the homework. Okay, let me see if I have the example here. Okay, I forgot which page I asked Yuan to demonstrate. Is this the page I asked you to demonstrate? Yeah.
Yeah, I think that was. I think that was the page. Yeah.
Okay. So I will ask you to start sharing and yeah.
Let's see. Right here. So I have the order written on the top here, so we can just refer to it. But so let's take a look at this first one. So we have left circle -2, right shift -1, 1 0 1 1 0, and 1 1 0 1 up. So we're gonna start in the parentheses since we need to calculate the and first. So we have 1 0 1 1 0 and 1 1 0 1 0. We have 0 1 0 0 1. Okay, so that's the result of the and. So this just is now 1 0 0 1 0. And then we're gonna right shift this by 1. So we can have for moving it to the right, we're gonna get 0 1 0 0 1. Right? And then finally, we're going to left shift this by 2. So we're going to go this way, 2. And it's going to be, so have 0 0 1. Then should be 0 0. Wait. No, wait, hold on.
Circulate.
Oh.
Yeah, circulate. Sorry.
Oh yeah, sorry, circulate, never mind. So we're circulating this. Yeah, okay. So this is gonna go back here. So we're gonna have 0 0 1. No, 1 0 0. Yeah. 0 0 1 0 1 here. And that's gonna be our final answer for that one. On this one, we see they gave us here the order is not and an or. So we're gonna see what the not is here. So it's not is very simple to do. It's just going to be 1 0 0 1 0. And we've got that. So we're going to do 1 0 0 1 0 or 1 1 0 1 0. So 1 0 0. That is a 1 0. It's going to be the or. And then 1 1 1 1 0. Yeah. Okay.
No, the and is first, I think.
Oh yeah.
Yeah, that's
yeah,
okay.
Yeah, okay. So this is going first. Yeah. Okay.
Yeah.
We have 1 1 1 1 1 1 1. So okay. Erase this so we're not the yeah. Okay, so then 1 0, our final one. No, that's not a 1. 0 0 1 0 0. I'm gonna do an or here. 0 1 1 0.
Yes, that's great.
And the final one, we go with not. You don't have any knots here, then we're gonna go look for ands. Here's the two ands, but we have to do these two first. So 1 0 1 0 and 0 1 1 0 0. Do it or 1 1 1 1. So we have crossed this out. This is now 1 1 1 1 0. And then this one is an exclusive or. So we're gonna have 1 1 0 0 1 1 0 1 1 0. Then it must be exclusive or, so 1 1 1 1 0. And then we finally do an and on both of them. So 1 1 1 1 0 and 0 1. Gives us 0 1 1 1 0. That matches.
That's great. Okay, that's great demonstration. Yeah, I think this it's not really super hard to understand. That's why we give you a couple of examples, not really too much. In case you still have some question, you can always post in the Google Classroom. And of course, we are really encourage you to try to find your answer first. But I know it's really, some of these are really a little bit more challenge, but as long as you have more practice, I believe you can get it. Okay, so now we move on to the topic number 3. This is a really interesting topic. So what does this program do? We use pseudocode. So it's not really bound with a specific language. So that means doesn't really matter you learn Python, Java, or even just Scratch. We are really talking here is the pseudocode. We don't really worry too much about the details about the language specific. Okay, so the first one is called the operators. We have the not. So you just remember this is not an expression, and you have this. Of course, you cannot really use the keyboard to type in get this one. So you really keep this, and then you have the real division or say division. Okay, I'm sorry. This is the multiply and this division, and then you have the modulus. In case you don't really know what's a modulus, modulus is really what left over from division. Okay, and then you have the plus, minus, larger than, smaller than, large and equals to, smaller and equals to, not equals to. So this is not equals to, I'm sorry, this one. And you have equals. This is really not the assignment. Instead, they try to make the comparison of two numbers. Okay, and this is and this is all. Okay, and we have the function or couple function like the abstract absolute value. You have the square root. You have the greatest integer, something like this. And we also use variables. So start with the letter, only letter and digits. We have the sequential statement, something like, oh, you have input a certain variable, and then the variable comes with the expression and with the assignment, and then you get output a certain variable. Okay, so that's really called the don't worry, Sophia, I will post I will post this PDF in the Google Classroom, so you will find that. So let me quickly find the answer for you. This is order. Okay, yeah, that's a good question actually. So now let's go to the another part of the pseudocode. Is a decision statement. If you learn anything about the Python or Java, you probably already get familiar with that. So you know the if Boolean expression, then something, else. Of course, this is just optional. You don't really have to use, but you have the statement over here, the end if, and you have the infinite loop or something like while loop. While this Boolean expression, you have statement and while. So just remember, all of this are not really bound to any language. It's just called the pseudocode, and it's for the ACSL. Of course, it's very common. So as long as you practice with that, you will get it. I will post the exercise probably in the next couple of days, so you can start to do some exercise with this pseudocode. But if you don't really finish the bit flipping yet, so you can continue exercise on the bit stream flipping. Okay. So now let's move on to here. We also have the definite loop. So that means you have the for loop. For this start with certain value and then end step increment. In case you don't really fully understand this, I strongly suggest you to go through the YouTube video I post in the Google Classroom. In general, that means you have a loop, you have a start value, you have an end value, and each time you are increment by a certain value. So for example, I have for I equal to, yeah, this is probably too big. for I equal to 3 to 10, and step 2. What that really means is that, I hope I can move this down. Okay, so this means you have the start value is 3, end value is 10. Of course, this is not a great example, but anyway. So what the value you will get for each loop is that you will get start by 3. Gee, why can I say it? Okay. I'm sorry, I'm not really very good to use this, so you bear in mind. Bad. Okay, so you have the 3 first, and then every time you are increment by 2, so you have 3, the next one will be 5, and then the next one will be 7, the next one will be 9, but you will not really go to 11. No, because your end point of the largest value is 10, so you will have the loop through will be 3, 5, 7, 9. Okay, so that's how this works. And of course, we have the arrays. The arrays here, you have the one-dimensional array, something like the A5, or you have a two-dimensional array, A23. So what this really means, I'll give you some quick example. Yeah, I just hate this. So, okay, so I totally clean. So let's say what's a A5? A5 means you have a one-dimensional array, but you have that up to, it's not up to, you only have 5 elements. So that means you have 5 numbers. For example, you have 1, 3, 5, 7, 9. So that's a one-dimensional array. You have this. That's perfectly fine. Or you have the two-dimensional array, A2, 3. So let me try. Gee, that's not right. Okay. So you have here A23. So that means you have 2 rows and each row have 3 columns. Okay. So what that really means, you have 2 rows. So one row each row have 3 elements. So you have the first one 1, 2, or 1, 3, 5, for example. Then the second one you have is 5, 7, 9. Okay, something like this. I just give you some quick example. So the first one means how many rows. The second one means how many columns. Okay, so totally will become 6 elements. Okay, so that's really called the two-dimensional array. Okay, and you do not really have to worry too much about each of these details because we are really used just pseudocode. Okay, then we have the strings. Strings can contain 0 or more characters. So you can see some string like this. They have the string length, and then for each of this character, they have a location, right? But it starts with 0. Okay, so the position is start by 0. So the first one is 0, position 0, position 1. And this one means eighth. Okay, so this is the first string, right? So that's a whole string. And then what this really means is take the first 3 characters, start on the left. So that means start on the left because this one, they have no number in front of this column. And then you have first 3 letters. So that's ACS. That's the first 3 letters. And then you have start from the right. So that means this part is empty. And you take the last 4 letters. So the last 4 letters is this 4, DTPD. Or you can say, oh, I want to start at certain location, start from the location 2. You just remember, we are indexed by 0. So that means the first location is 0. This location is 1. This location is 2. So start from location 2 and end at location 6. So that means you have the 2, 3, don't forget the space, 4, 5, 6. So that's how you get this string. Or you say 0. So that's position 0 only. Say, okay, this is A. Okay, so you can always try to manipulate the string like this. I suggest you to practice a little bit about this. This is sometimes get confused easily. Okay, so okay, so let me probably practice a little bit here. So let's try to give you the chance to practice. And I write a couple of questions here, so you give me the answer. So ACE 4, what's the answer for this? Okay. Yeah, if you know the answer, please show me the answer. ACSL, that's great. ACSL, oh yeah, try to, I know Sophia, you made that by mistake. Try to, yeah, keep the exact same case, kept the case, yes. Yeah, just because they are string, you don't really change the case, okay. Okay, let's try to practice a little bit the second one on to this. PD, good, PD, great. Okay, so now let's try to practice 3, 4. It's very cool. Okay. And practice one more 3. Okay. Yes, that's a good question. If you see something right like this, okay, use this as baseline. What this baseline means, you are start from location 2 up to the location 6. So if you use this as a baseline, you can understand. This means you don't have 2. You don't have any number here, right? So that means you start from the first letter. So they don't really give you any choice. You just start from the first letter, but you take the first 3 letters here. So 1, 2, 3, you take the first 3 letters. So if you write something like this, means, oh, you have not really specific what's the end, what's the last location. So that's the last of this string. That's the last location. You only take from the last location and you take up to 4. You take 4 characters. So that's how this works. Yes. That's really, yeah, I know this is not really very clear, but let me highlight it so you probably can see it clearly. Yeah. Okay. Yeah. Okay, so that's very good. We have a little bit time. I like Yang to share his screen and go through this. So this is not very challenging exercise, but I believe this is something very good, and we can introduce this to you guys.
Just hold on one moment while I get this set up.
That's see. Okay.
How does this work? Why are we not? Okay, let's do this. Let's see. There was a comment. Okay, there was. Okay, so here was what the program says. And the problem about this is that it actually might be a little complicated to do this by hand, since we have a lot of for loops here, and that means we're gonna have to do a lot of work if we actually want to do this by hand. We're gonna have to like modify the array that we have going on here too. So what we're gonna have to do is we're gonna have to write a program to solve this. So let's get my code editor here. Let's see. So how is this? What is this? Oh, I see what's going on. What am I sharing? I don't know. Well, let's get my code editor here.
Yeah, don't worry, take your time.
So, well, now we can't see the actual problem anymore. He's, where? Can you see the screen?
Yes.
All right. So you can see my code editor and the problem right now. Can you see it side by side?
Yes.
All right. Yeah. Okay, cool. So we can just start writing this out in Python. So we have right here, we have an array. So first we want to say, define this array. So we can say 1, 2, 3, 2, 4, 6, 3, 6, 9, and 4. The next thing that we want to do is that we are going to just start writing out. So we're going to define s equals 0, and then we're going to go to for loop for I in range 1 to 5 because it stops right before 5. For j in range 1 to 3, and if I is less than j, so write that. And what we're going to say is that so here's where we need to be a bit careful. The problem about this is that on these arrays, they're accessing them by 1, but in Python, they start at 0. So what we're going to have to do is we're going to have to subtract. So that's going to equal to a minus 1, a minus 1. Okay, so otherwise, we're going to say a I 1 equals to int a I minus 1 minus 1 divided by 2. All right, so that's that. And we don't have to write the next I next j because Python does that for us. We'll just print s. Then we can try running this. Oh wait, we didn't add the s, right? Yeah. So right at the end, the s equals to s plus a I minus 1 minus 17. Hold on. Should be 17 if that's the answer, if I did this correctly. Oh, I know why. I had 1 before. Yeah, okay. So 72, that's the correct answer. That seems more right. All right. And that's how we do this problem.
That's great. Would you please just use that table to explain a little bit? Just not really necessary to be inside the Python program. I mean, if you put on the paper, you probably can also get the same result.
Yeah. So we can stop sharing that. Let's share the whiteboard again. So we can go through this program manually as well. I don't want to erase all that. So we just have to like write down on paper what's S. We need to keep track of what I is and what J is. So let's just go from here. So S equals 0. We can write down here S is 0. And for I, we start with I is going to be start at 1. And then J is going to start at 1 as well. And if I is less than J, that's not true. So that means we're going to follow this path right here. So Aij equals the int Aij minus 2. So we look at the lookup table. So the way we do this is that we have I and J are equal to 1 right now. So that means we have to look in so the column 1 and then row 1. So then the value of Aij would be 1. So it means it could be 1 divided by 2. That's 1/2. The int makes it just 0. So that means this would be 0. And we would just do this again and again.
Yes.
Until we did this 12 times.
Yes, that's great. Yeah. Yeah. The whole point is that Yuan explained to us what's really we can do use the program. But if you are really just go through the exercise or even in the contest, you only have 30 minutes. So you don't really have time to finish the program, most likely. You still need to learn how to use the paper to resolve this kind of problem. I mean, find the solution. So it's not super challenge, but I strongly suggest you to exercise. I will post the question on the Google Classroom, so we will have chance to practice a little bit. Okay, so we are pretty much end of our meeting. And just remember, we have to check the Google Classroom couple days a week. If you have any question, post on the Google Classroom and try to review this tutorials. I post the files, YouTube link, and yeah, we are not to discuss the technical question in the WeChat group. So we just need to practice. Make sure you submit your answer. Don't worry about that if you get something wrong. It's always some possibility we get somewhere we are not really fully understand or even misunderstand, right? So, okay, again, I think we are work together, prepare for the contest number 2. Remember, the contest number 2 will be the time frame. Let me see. Okay, they will between the February 25th to March 2nd. I'm not really finalized the timetable yet, but we have the contest number 2 in our pipeline for the next couple of weeks. So yeah, practice and prepare for that. Thank you so much. That's the end of tonight's meeting, and I wish you have a great weekend. Bye.
Thank you. Bye.
Thank you. Bye.